Hey, Carly.
Hey Wade, today we're going to continue to talk about your favorite topic of visualization.
Which one do you have for us today?
So today we're going to talk about a visualization called a box plot, or a lot of times you'll hear these referred to as box and whisker plots because the visualization itself has a box and then two whiskers. So box plots are really nice for quantitative or numeric data. So I think we're just going to go ahead and draw one and kind of explain the parts of it in order to help you get familiar with the box plot.
Awesome.
So you have a data set for us, right, Wade?
Yeah, so one data set that I think will work really well and something that's really interesting to explore with a box plot is the probability words data set.
Ooh,
And
yes.
this data set has a number of different words where people describe the probability they feel about a particular word.
Perfect. So I think we're going to go with the variable we believe.
Yeah, so we ask people if we believe it's going to rain tomorrow, what probability do you feel it's going to rain?
Yes, and they could answer any probability between 0 and 100.
Correct.
So the box plot, first we're going to talk about the box part of the box plot. And the box is going to have three distinct points. The first one is going to be something called Q1, which stands for quartile 1. And it's essentially the 25th percentile. So, Wade, can you tell me what the 25th percentile is?
Yeah, so I brought up the data set and we believe the 25th percentile is 66.
66. So I'm going to go to, here's 65, 60, 66 is a little above that. I'm going to draw the first part of my box, which is just a line. And this basically means 66, so I can even write that here, 66 is the 25th percentile. This means that 25% of people who answered this survey answered a probability less than 66% for us saying we believe it's going to rain tomorrow. The next number that the box shows us is Q2, which is the second quartile, also known as the 50th percentile. And the 50th percentile has even another name. The 50th percentile is also the median. So it's the point in the data set where half of the data, 50% of the data is below it and 50% of the data is above it. So Wade, what's the median for we believe?
In the probability words data set, 75.
75. So 75 is about right here. I'm going to draw my second part of the box, and then I'm going to draw the third line and make this into a box. But right at 75, this is saying half of the people actually answered a percentage less than 75, and half of the people answered a percentage above 75. And then the last part of the box is what we call Q3, or quartile 3, which guess what that is? Guess what
It seems like
percentile?
25, 50, 75th percentile.
There we go, 75th percentile. So Wade, what do we get for Q3?
We have it as 80.
80. All right, so relatively close to the 50th percentile, right at 80. I'm going to draw my line, and then this is a box plot, so I'm going to make this into a box. And with any box plot, if you look at the box, the first line is always going to be the first quartile. The line in the middle is always going to be the second quartile or the median. And then the last line is going to be the third quartile.
So because Q1 and Q3 are 25 and 50, or and 25th and 75th percentiles, we know half the respondents felt that the data for we believe was somewhere between 66 and 80%.
Yes, exactly. And there's actually a statistic that can tell us this as well. And it's called, there's a lot of abbreviations here, but it's called the IQR, which stands for interquartile range. And that is essentially just Q3 minus Q1. So it's the 75th percentile minus the 25th percentile. So like Wade said, it's the middle 50% of our data. That's a great observation.
So doing the math right there, 80 minus 66 means our IQR is 14.
Perfect. And that is essentially how thick or how wide our box is. So I said earlier that box plots are sometimes called box and whisker plots. So let's go ahead and figure out the whiskers. So in order to draw our whiskers, we first need to do one thing. We need to decide if there are any outliers. And we're going to go into a lot more detail about outliers throughout this series. But just to kind of sum it up, outliers are points that are really far away from most of the data points. And there's a mathematical calculation that we can use to find them. And it actually involves these quartiles. So to find the outliers, any low outliers, so small numbers, are going to be numbers that are less than Q1 minus 1.5 times the IQR. So we can do this calculation and get basically our limit, and then any numbers less than that are going to be considered outliers. So Wade, are there any outliers for the We Believe data set?
So the first, I'm going to see what that low outlier value is. So Q1 is 66 minus 1.5 times 14 is going to be 66 minus 21. And 66 minus 21 is going to be 45.
45. So low outliers would be any data points where the person said that the We Believe probability is lower than 45.
And the minimum person said that We Believe was just 0.1. So we definitely have some low outliers.
All right. So we know that we have some low outliers. So that means if we had no low outliers, we would just draw our whisker to the minimum value. But we actually have a low outlier. We have multiple low outliers. So on box plots, they're really easily visible because they're plotted as single dots. So you said there was one at 0.1, right?
Yes.
So I'm going to go ahead and draw my low outlier right there. And then were there any other numbers less than 45?
There were two more. There was one person who responded 25 and another person responded 40.
Another person responded 40. So there were 3 low outliers. And okay, so now I can go ahead and draw my whisker, my lower whisker, because I know these are the outliers. And then the lower whisker goes at the lowest number on the list that's not an outlier. So wait, what is that for this variable?
Someone responded with exactly 45.
Okay, perfect. So I'm going to draw my lower whisker. Usually it's drawn like that to go right at 45. So the nice thing about box plots is that if your data is skewed or has a lot of outliers, you can look at it and really easily see that because the outliers are singled out as single dots. So we're going to do the same thing for the top whisker. We need to figure out, are there any high outliers that we need to draw first? If not, we can just draw the top whisker to the maximum value. So high outliers are any numbers that it's very similar to the formula for low outliers that are greater than Q3 plus 1.5 times the IQR.
So doing the math here again, it looks like it's 80 is Q3 plus 1.5 times 14. So that's 80 plus 21, or 101 is the end of our high outlier range.
Ooh, 101.
And looking at the max value for this data set, the maximum value is 100. So we don't go past the high outlier range, and there's no high outliers.
Yeah, so remember we said high outliers were any numbers bigger than 101. And this was a probability word survey, so the maximum value is 100. There's no numbers bigger than 101. So that means we have no high outliers. So to the right of Q3, I shouldn't see any dots. Instead, I can just draw my whisker all the way over here to the maximum value at 100. So this is the max. And then these are the 3 low outliers. And there is my box plot. And I can look at this and kind of get an idea. This is for the variable We Believe, kind of get an idea visually of what is in that data set for this variable. And like I said, this is good. Box plots are really good for data that are skewed or have a lot of outliers.
And we're going to find that Python has the ability to write a box plot built in. And we're going to see that we can create a graph that looks almost identical to this by using the command df.plot.box, because it's a box plot.
And again, Python saves the day by making it so that we don't have to draw these out. We can create a beautiful looking box plot from the computer.